All right, I think we're live. Let me just check real quick. Okay. All right, all good. Hello, everyone. So, yesterday we spent most of our time fixing a problem with the viewport. So I made this little checklist. If there's ever any like weird movement of objects in the scene and I'm debugging it, I'm going to go through these steps. I'm going to check the matrices, so the view and projection matrices and the model matrix. I'm going to check the coordinate space transforms if there are any in the shader. I'm going to check the viewport and if there's any culling happening, and also lastly the camera code. I mean, I don't think that's going to be a problem, but it could be at one point, so that'll be the last thing to check. I think I'm going to make a bunch of these checklists for the future, but yeah, that was pretty frustrating. However, it did give me time between yesterday and today to consider what to do next. I did do a bunch of like random stuff with shaders and things that I don't fully understand, so I'm probably gonna roll back the changes. Like the screen is just green right now. Excellent. I just got an encoding overloaded error in OBS, which is weird. Usually that happens when your CPU is too slow, but I'm only using 1.1% of my CPU with OBS. I'm not sure. Yeah, okay, so let's make this text much larger. And we'll have a look at main, actually. Yes, we'll have a look at main. So I've got some extra pipelines doing some stuff, but I'm just going to delete them, I think, and go back to what we had yesterday. Actually, I can't delete them. And I didn't commit it to Git, so I'm kind of screwed. That was a mistake. I think I just went on and like changed a bunch of stuff. Let me have a look. Debug pipeline, debug UI pipeline, point cloud pipeline. So I've added, two uniform buffers here to the fragment shader. Yeah, I remember now. So I was just copying some code and testing it out and seeing if I could get it working, but no. So I was going to start again. So let's do that. So the Vertex shader is actually going to be really simple. So that Vertex shader was just drawing a quad on the screen, basically. So like a big flat rectangle, because all the work was going to be done in the fragment shader. But let's put it back to what it was. And what it was, what are we doing again? Point clouds, drawing point clouds. So we had GL point size equals, I think it was 8. GL underscore position is going to be, oh god, I forgot about this. So we need the X position, which was going to be GL vertex index mod width, I believe. So we're going to actually have const int width, or maybe chunk width. Chunk height. These are all going to be 8 at the moment. I might change them to something larger later. Chunk depth is going to be 8 as well. So Y was, oh damn, I wrote it down in here, right? Yeah, nice. I mod width divided by width. Okay, so and then Z was vertex index mod, no, divided by width times height, is that right? So I've got here 31 divided by 12 is 2.5, so 31 divided by 12, 2.5, and this is the second layer, yeah. Okay. So divided by width times height. Now, do I need to... Yeah, I think that's fine. Whoops. So position is going to be vec4 x, y, z, 1. That's pretty much it. I think that's what we needed. Now the fragment shader. It's very different, so I'm going to just delete everything. I was trying out some SDF stuff, which is what we're going to build up to eventually. So we've got nothing coming from here. So what do we do? I guess we just say out color is going to equal to vec4, and then there was density actually. So if we look at the uniform in the main file, there's two uniform buffers. One of them I think is called densities, right? This one. So it's got 512 densities, which means it's going to be a location is 0, I think. So location 0, let's see. I need point cloud uniform buffer. So there's 2, binding 1, binding 2. It doesn't actually say DST binding. Yeah, so it's layout location 0. Uniform, I'll just call it UBO, I guess. And this is going to be vec4 densities, 128 of them. And the reason is because all of the values in this kind of buffer, if you put them as a float, then they get separated on the next 16th multiple of 16 bytes. So you can see this is a float at byte 0, and this is a float at byte 16. So this is an old render doc that I had when I was figuring this out. And then the next one's at 32. But actually you could fit 3 more floats in between these. And the way that I've decided to do that is just to make this vec4, which is fine, I think. And then we can have something, or maybe I actually get the density in the vertex shader. Right, and then we do out flat density, flat float density. So flat just means it's not going to get scaled. So I believe by default, if you send something from the vertex shader to the fragment shader, it'll get scaled between the vertices. Although I haven't double checked if that would happen in this case, but yeah. And then we say out density equals something like densities. No, actually, I believe this could be. Could this be a 3D array? I wonder if that would work, or if that would just not work. Let's have a look. So we're gonna have to move the other uniform buffer here. What does it actually have in it? So I might need it later. It's got camera position. Yeah, why don't we keep that? Yeah, we'll keep it, just in case. I just have to put it in the shader. Location equals 1, uniform, camera, I guess. And it was just a vec4 camera position. And I can put this one in, well, I guess I'll just put them both in the vertex shader. Right now they're both in the fragment shader, but that's fine. We'll just change that, hopefully, somewhere up here. Sorry if I'm coughing a little bit in this stream, I'm a bit sick. Alright, so the point cloud pipeline, push constants are available in both. Right, I haven't used the push constants at all. I guess I should put them in the shader. But first, let's find where we do this, and we say find the descriptor sets, push constants for 2 things, and we're drawing. We don't want to draw 4, we want to draw 512 vertices, and I think that might be okay. Error compiling, point cloud. Okay, let me have a look. What's the error? Out color is undeclared. Okay, fair enough. And not enough data provided for construction. And I missed a semicolon. Okay. Okay, semicolon is here. I didn't even finish this shader, that's probably why. Layout, location equals 0, vec4, out vec4. We can just do red, I guess. Or we'll do, I think what we had last time was density and then 1. So there was an error in the code that I showed yesterday. It was because we were only updating the first 2 layers. What's the problem now? Cannot apply to a uniform buffer or block location. What? Oh, did I write location? I meant to write layout. Oh, it's binding. It's binding, not location. This is binding. Binding, and this is location. This one is going to be location, location, yeah. Okay, shaders are compiled. And I don't see the point cloud, which means I messed something up here. It could be that I changed the render mode back to polygon. Yeah, fill. So this needs to be point, and this needs to be. Actually, you know, that's fine. This needs to be point list. Okay. All right. So we got. Okay, we have a single thing in the middle of the screen. I guess I still need to multiply this by world position. Oh crap, how did I get that? World position is... No, that should be fine. But maybe I need to multiply by the camera stuff. So, uniform, push buff, push constant. VP and model, although we don't use model. But this should be fine, I think. Alright. Yeah, cool. So, alright, so a bit of a problem. We're only drawing 1 layer. And we got the same bug with the coloring. So let me fix these one by one. We're only drawing 1 layer because the Y Is the y coordinate incorrect? Yeah, that's definitely incorrect, because that's going to give us the same value as x, and then we're just dividing that by 8. Which doesn't make sense. I don't know why I put that as the y. It should be, let's see. So 19 divided by 3 is 6. That's not correct. 19 divided by 4 is 4.75. That's also not correct. 19 mod 3 is 1. Okay, 19 mod 4 is 3. Divided by... Okay, so 19 mod 3 gives us 6. Okay, and then divided by width gives us 2. No, that was correct. Okay, so this one is correct. Interesting. Let's see. Let's try this one. 34 mod 3 is 1 divided by 3 is 0.3. So that's definitely wrong. So this one just happens to work. Okay, so 34 divided by 3 is 11. Mod 3 is 2.3. No. Well, this isn't even... Okay. $34 is this number here. So we want to get 0, 1, 2, 3. Right? We want the value to be 3 point something. Okay. And we can only use the x. We can only use the index and the width and the height and the depth. So what would the value actually be? 34, if we divide that by the z, which would be 3, gives us 11. Okay. And then if we divide that by 3 again, we get 3. I don't know if that's correct. So 22 divided by 3 divided by 3 is 2.4. No. Okay, let's work this out a different way instead of just randomly guessing. So if we go across from 0, 1, and then 2, and then we go up to the third one, we know that 3 mod 3 is going to be 0, and then 6 mod 3 is going to be 0. So that mod doesn't tell us anything about the height, right? But 3 divided by 3 is 1, and 6 divided by 3 is 2, and then 9 divided by 3 is 3, right? So basically we just divide it by the width, I guess. So we could do 34 divided by 3, but that's incorrect. What if we did 34 divided by width times height, 3 times 12, that's 3 times 4, is 2.8. Oh, this is what we came to yesterday, isn't it? Wait, that's the Z. 0, 1, 2. Let's choose a different number. Let's choose 9. 9 divided by 12. It's going to be 0.75. So that gives us the Z. Okay, that's this. Okay, so dividing by the width gives us the height. But it could be divided by 34 mod 3. Huh, interesting. So that gives us 11. If I then divide, why is that wrong? Okay, I mean, in my head it's wrong, not in the calculator. 22 divided by 3 gives us 7. So if we look at this, we got 1, 2, 3, 4, 5, 6, 7. We're in a seventh row if these were stacked up like this. Okay, and so how do you figure out this? I guess you divide by the height. 1.8. That's wrong though. That gives us the depth again. No, that doesn't give us the depth even. Zero, 1, 2, 3. That's fine. Okay. Now 12 divided by 3 is 4. So 12 minus 12 divided by 3. No. What am I doing? 12 divided by 3 is 4. So we're in the 4th row, which means we're actually on the 0th row. So divide by, no, I can't do a divide. It's got to be mod height. Let's see, 15 divided by 3 mod 4 is 1. Okay, 30 divided by 3 mod 4 is 2. Okay, that's what it is. I divided by width mod height. It's got to be like this. Oops. Okay, there we go. Right, so this has to be height. But that's exactly the same. In our case, it's the same number because it's all 8s. But anyway, now it should be correct. So that gives us the depth. Yeah, okay. So it's actually just I think the indexing into this array is wrong. I gotta check in render doc. Okay, we've got our one layer. Let's have a look. So 8,192 bytes needed. 2048 supplied. So if we have a look here at our densities, we seem to have the problem that I was talking about. So how do I fix this? Maybe I did just use 128 here. And then we just do GL, the index is going to be what? GL vertex index divided by 4? No, plus, hang on, so the GL vertex index is going to be 0, 1, 2, 3. Yes, so divided by 4. But then we need to get the correct component, which is going to be Vertex index mod 4, I suppose. Is that going to work? Undeclared identifier. Oh, is there a capital? Yeah. Okay. Well, that gives us the colors are correctly spread out across there. That's nice. Still not showing the full cube, but let's have a look. And this is why you should always commit your changes. Because I made a bunch of other random changes and then we had a problem. Okay, so we've got a bunch of densities in here and they all seem to be tightly packed. That's great. However, when we draw this stuff, doesn't seem like we're getting the right values, hey? So the y seems to always be 0. Unless, what if I do something like this? Plus yeah, okay. So that, I mean, that's not what we want, but interesting. That's weird. The weird thing is, I would have expected more values. So what if I do this? Plus, the only thing that I can see that's changing here is the vertex index. So I'll do vertex index mod 4 again. Maybe I'll do like mod 3. So it'll be a little bit off. Yeah, I just wanted to see if there are more values. Okay. That's odd. So we're definitely drawing 512 points, right? It says in here, we're calling a draw command with 512 vertices, one instance. Yeah. And can I see any more information in here? Not really. This looks fine, I think. Yeah. Okay, I'm just going to experiment a little bit with this. So I might have messed this up. So what if we just set the y position to the index and then we should get a spiraling up. Oh yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah. This keeps going. That's good. So yeah, this is just wrong. How is this wrong? Let's see. So divided by width mod height. Ah, I did mod width divided by height. That could be the problem. There we go. Cool. Great. So now we've got all our densities properly showing. Yesterday we were only showing the first two columns, or columns and rows, or layers, I guess. And the reason is because of that padding issue that I was just talking about. So the next step after this is, okay, actually first I'm going to make the chunk bigger. I think it's too small. Let's do a 32 by 32. And that means we need to multiply this by 4. And we also need to change the stuff around in here. So we got, where is it? There's a size, so here we go, 8 by 8 by 8 by 8. So let's just make this chunk width, chunk height, chunk depth. I'll have to make those variables soon. And then we got to do something down here like chunk width times chunk. Actually, we can just make that into a chunk count, chunk total. So what did we say? 32 by 32 by 32. And chunk total is going to be these three multiplied together. So I'm going to try something here. I'm going to grab these lines and I'm going to do yank join. Then I'm going to paste them here and do that. That's kind of cool. I think actually I could have done, let me try that. So I'm going to do yank join, oops, yank join, and then I'm going to do paste. No, I can't do it like that. Okay, one more time. Oops. Yank join, and then I'm going to do a multiply. And what happens if I paste it here? Oh, nice. Well, it's not bad, I guess. I wonder if I could do a multi-character separation. Just messing around with the editor here, trying to make it a bit better. Yank join, and I do space, multiply space. We'll see if that works. No, it doesn't. No, that's alright. Still, pretty cool. So, chunk total, so we're gonna put all the values in there, and then I think we need to go to the draw. So the draw with a 512, that's just gonna be chunk total, tutu. Very good. We should have a much larger, there we go, it's pretty big. Much larger set of dots here. So these are all a meter apart, which is the same size as a Minecraft block. So I thought maybe we should try, well, that's totally incorrect. Maybe we should try rendering cubes first before we move on to much more difficult things. So this is going to have to be split, I mean not split. So I've got only half, is it half? Is it happening over there? Yeah, it looks like half of the values have densities, which means my multiplication was totally off, I think. What is 32 cubed? Huh. 32,768 and divided by 4 is 8,192. Yeah, that's a lot less densities than we had in there. Okay, that's a lot of values now. That's crazy. Is that working though? No. What's the problem? The range is greater than the max uniform buffer range. Huh. So we can't put that many things in a uniform buffer. Okay, good to know. Hmm. Yeah. Mm-hmm. Mm-hmm. Okay. Why don't we try 16? And then this would be... Mm-hmm. 1024, yeah, okay. Oh, hey, the dot wolf says there's a 16 kilobyte up to 64 kilobyte limit on uniforms depending on the platform. Thanks. You can use a storage buffer. Okay. In this case, 1024 is a 4 byte. These are 16 bytes. So this is going to be the limit, I guess. Which is... It's fine. I don't really mind about the chunk size right now. I think 16 will be okay to just test with. It's still pretty big, I think. Yeah, there we go. Cool. Alright. So, that's cool. Now, what I was thinking was we could actually use some noise to generate the densities instead of just making them random. And so if we go to densities, we've got this thing here. I suppose I will just include the noise library. I think it's in math noise. And there's a bunch of functions in here. So we're going to do 3D. Best use as a fallback. This is recommended for 3D terrain and time varied animations. I guess we'll use this one then. So we'll just say seed of 0 for now. And the coordinate's going to be... Well, actually, why don't we do a loop here? So for x in 0 chunk width. Right, yeah, what am I doing? There we go, that's good. We can just set this to... I'll just do the easy way. Looks 480. The dots are destroying YouTube's video compression. That looks 480p every time I run the game. Oh, really? Huh. That's interesting. I'm streaming at 11,000 kilobits per second, so that's enough, right? Well, we're not going to be drawing dots for much longer, so hopefully that won't be a problem. Right. What's wrong with this? Oh, we need actually... Whoops. This function takes 64-bit floating point numbers. Which was not the problem. I do not have an equal signs here. Well, it is a problem, but... Okay. This is definitely not going to work. I'm pretty sure. But let's have a look. So wait, actually this returns a value between... What is it? Doesn't say. I think it's between -1 and 1. Yeah. So we need to normalize that. So we do +1 divided by 2, right? Okay. That looks kind of the same because we don't have any amplitude or anything here. Let's see. Build. Everything is building fine. So I guess I can look at the values actually. Let's do that. Launch. So they should be sort of gradually increasing and decreasing rather than just being random between 0 and 1. Let's have a look. So the buffer's here. Here are the densities. Yeah. So they're kind of going up. That's a pretty big jump, but I think that looks fine. So if I want to increase the amplitude, do I multiply the noise value? Actually, I have an old file here where I did a bunch of terrain stuff. I have a couple of them. Is it this one? Here we go. Right. So, interesting. Multiplying the positions by the frequency. I don't think you should add stuff to the seed. Although I guess it would be deterministic. Multiply by the amplitude. So in this case, we are setting amplitude to 1. Well, that doesn't do anything then. Oh no, we're actually, okay, we're halving it each time. Okay, I'm gonna grab this. I'm gonna go back here, I'm gonna put it here. So let's see. This is 3D noise. We don't have a frequency value here, so let's just actually let's make it a function. Yeah, we'll just copy this function. So I was using the Minecraft world generation stuff, which is pretty cool. So this is going to be 3D. Whoops. Not 2D. It's going to be a little bit different. Cool. Noise 3D with octaves. 3D with octaves. So the seed we're just going to say 0, XYZ is going to be... Oh, why did I delete that? Whoops. And we need to pass in what amplitude, frequency, and octaves. Okay. Well, I don't know what the good frequency is, so let's see what I was doing here. Continentalness frequency. Okay, 0.0025. And the octaves 4. Okay, which is something like that. What's wrong with this? Oh. It's not a vector. Great. So this is, yeah, there we go. Wait, no, still a problem. I misspelled frequency. All right, hopefully we get a kind of different looking result here. Great, it's all purple. Now, what does that mean? Let's have a look. Are the values just changing too slowly? Or are they not changing at all? Let's see. They are changing quite gradually, which means the frequency is probably too low. I'll just run it in RenderDoc. Yeah, there we go. Okay. Alright, yeah, I can see that. Alright, so we've got basically densities between 0.5. Is anything above 0.5? Yeah, 0.6. Okay, good. Good. Yeah, the normalization is working as expected, I believe. That's cool. So, I could probably even reduce this a bit further. And then what I want to do is have a look at the shader, which I realize I've still called a point cloud and I didn't commit it. So I'm going to commit this right now. Point cloud, rendering, working on 3D terrain. Yeah, the capitalization and non-capitalization of that sentence is cursed. But the thing I wanted to look at was point cloud vertex shader, because we can, given this density, we can also change the point size. So why don't we say something like, the point size is 8 right now, so why don't we say, wait, what does that mean if I have a point size of 8? Because when I move close, it's really tiny, and when I'm further away, it's larger. So it's just 8 pixels. I think it's just 8 pixels always, depending, no matter what distance I am from it. Which means we could probably change the point size based on the distance from the camera to look like cubes or something, but I'm not going to do that right now. I'm just going to say 16 times 8 plus 16 times out density. Something like that. Let's see what that looks like. Okay. No, that needs to be a much larger number, I suppose. Maybe like 64. Oh, jeez. That's not what I expected. Of course, I shouldn't really expect this to make sense. I need to actually make a 3D renderer, not using points, I think. Okay, why don't we try that? We'll try rendering a cube. So I'm just going to put this back to 8. Gonna say great, good job. We're gonna make a cube renderer. Gonna grab this. It's gonna be pretty much the same, except we don't need a point size. I think this. I don't know. How is that gonna work? Because we're not gonna just draw each vertex. I mean, we're not going to use one vertex per cube. We're going to have to use more. Unless we make it a 3D box distance function. I kind of wanted to do rasterization first though, because I'm still brushing up on my shaders and linear algebra and stuff. So I don't really want to get into this yet. Yeah, okay, that's fine. We'll see if we can just draw cubes, eh? So drawing a cube, I'm gonna say we actually have a way to draw cubes already. It's in the debug shader. Right? We've got cube vertices. We've got a uniform with a bunch of positions. Yeah, so we can just copy this. So let's say, grab this. Now, instead of the vertex index being, no, this would be the position, right? Oh, we can't do it like that though. Because the vertex shader is going to run once for each vertex. I think we could still use this though. So this is actually going to have to be. Hello, Emilio. How you doing? Right. So the thing about this cube vertex shader is we actually use 14 vertices per cube, but with the point cloud, we're using obviously one vertex per position. Now, could we do something where we use the vertex index divided by 14 and then we just send in 14 times more vertices? I think that might work. Let's see. So if we do like cube index divided by 14, because it's 14 vertices per cube, and then we change all of this to cube index. That might work, although the out position is going to be different. So we're going to need this. This would be cube index, right? No, this would be, yeah, vertex index mod 14. That's fine. And then this would be position here. Oh, we're using instances, right? That's right. So actually, this could work. Okay, this could totally work. What am I doing? So these X, Y, and Z, they would actually be instance index. Yeah, why don't we do that? So we'll send in 16 by 16 by 16 instances, and then we'll use the vertex index to calculate the cube. Whoops. So like this, vec3. Oh, where's the position? Position. So we got the mod, the vertex index mod 14. Yada yada yada. I think this will work. Okay, and then we got to do what? We need a fragment shader, but I think I'm going to just use the same fragment shader. So if we go back to main and we go to the pipelines, do I want to make yet another pipeline? How many do we have now? 1, 2, let's see, pipeline. 1, 2, let's get this, 3, 4, 5, 6. Okay, well, that's a lot of them. And we'll just make a seventh one. Point cloud. This is going to be cube pipeline, I guess. Seems a bit strange, but should be all right. So basically just going to grab all of this code, copy and paste it, replace point cloud with cube, and call it a day, I think. Probably forgot a bunch of stuff, but that's okay. That's where the errors come from. So the uniform buffer size is going to be the same. The vertex buffer, yeah, we don't even have a vertex buffer, that's right. Cool. Oh yeah, this is going to be different, so we're not using cube frag, we're going to use point cloud. We'll just use the same one. Actually, I'm going to copy it because I will forget that I'm using that one, and then I will not be able to figure out why there's errors happening later. So I'll just make another copy of this. Frag.glsl. That's not right. There we go. Okay, now I need to run the build, and we got some errors in the cube shader because positions is undeclared. Left side of that, so line 46. Let's have a look. Positions, right, so that's not a thing that I have in this shader. What is it in this shader? Positions. Oh, right, yeah. Yeah. So the position we actually have to calculate differently. Position is going to be the X, Y, and Z that we got from up there. There we go. Cool. So we're gonna, yeah, we're gonna do 512, or however many it is, instances of 14 vertices. Yeah, that's right. Let's see, did that build? Okay, the cube shader's built. So now I've got to go down to where we call the not this cube graphics pipeline. Point cloud graphics pipeline is down here. And we're going to do another, actually, yeah, I'll just copy it. It's fine. I'll comment it out though. We're going to do cube, cube pipeline, I guess. Okay, now when we draw, we're going to draw chunk total is going to be the instances and then 14 vertices. And what is this? Cube push constants. So apparently I didn't make the push constants that I need. There's a lot of duplicated code because we're just doing a lot of experimenting. Okay, let's see. Can we build? We can build. The shaders are taking longer and longer to build. Alright, we got a problem, which is we're using a point list, but we're actually trying to draw, and we're not using point size. Okay, yep, that makes sense. So the problem with copying pipelines is you might forget to set settings. Like this. Point list, we don't want that. We want triangle strip. And fill and cull mode, we'll just leave it on none, that's fine. I think that should be okay. But I feel like I'm forgetting something. Let's see. I'll actually run it in render doc. Okay, the screen is blue. Not great. Interesting. Let me see. If I run this again and I move to the sun, okay, here we go. I'm at the sun. Okay, there's just a big blue box. Right. Cool. So I think we're drawing cubes, because that's just a big cube of cubes, I guess. So the problem is we're not scaling, we're not doing anything with the color based on the density. Looks like the density value isn't being set properly though. Right, because in our cube fragment shader, we still should have some red in some of those cubes, but they're all blue. So that's telling me this instance index is not correct. This is not the point cloud pipeline, this is the cube pipeline. Okay, so what's happening? So we're sending in, did I say, I did index, didn't I? Yeah, instance count, vertex count, instance count. Yeah, we're not using indexed drawing. Did we need to? I don't think so. That was just for the model. So for debug drawing here, yeah. Just drawing the max shapes and yeah, okay. Okay, the reason it's blue, I don't know. Let's see if we can change the size though. So, how do we scale down the cube? I guess we multiply it by a scaled model. Is that right? So right now our model's just an identity matrix, but let's say, actually I'll try it the simplest way possible in here first. Where is it? Here. If we say MVP model is going to be glsl.mat for scale. Actually, I don't even need this. Scale by 0.5. That's going to be our model matrix now. Is it going to change this? Whoa. Yes, it is smaller. It's also not, they're also not separated, which means this position is not right. I don't know if we can, I'm just missing something. So the problem with that is by scaling the model, we're also scaling the translation to be sort of closer to each other, which means we're not seeing separated cubes. So we've still got to set the position to be the same in terms of the center of the cube, but each vertex needs to be translated or scaled based on the model. So I guess we could actually just multiply these vertices by a number. Would that work? I think that would have the same effect. Right, because for some... That's interesting. Well, all the vertices are positive. Oh yeah, that makes sense actually. And then we just subtract 0.5. Okay, gotcha. Let me think. So if we want to scale up a cube or scale down a cube, we're going over each vertex in order. So first we have this vertex, which is the, top. Where's that cube that I had? So we have, let's say we have this one first. Okay, and we want to scale the cube. So we kind of want this to be down a bit. Okay, that's fair enough. But then the next vertex is the X and Y, let's say. So that would be this one. We also want it to be down a bit, but we want it to be in as well. So this one would also have to be in. So this couldn't be a 0. Do you get what I'm saying? So it'd have to be like an offset. So you'd have to like multiply and then add a scaling factor to particular vertices, or subtract depending on where they are. Am I overcomplicating this? Maybe. Okay, what if we do using a matrix? We scale it and then we translate it. Translate it. Oh, I can't do... Oh no, I have to multiply these together. Okay, so then we translate it by 0.5. Is it that way or the other way? I guess we'll find out. Oh. Okay, so that gets us sort of back to what we had just before. Interesting. If I swap the order of these... we get the same result. That's unexpected. Okay, what if we scale it by 0.3 and then translate it by 0.5? Yeah, they're all still next to each other, I think. Let me change the color somehow. So the color is supposed to be being set by the density value, right? But it's always blue. So it's kind of telling me that the density value is not ever very big. Let's have a look. That looks very blue. That just looks like blue, blue, blue. Big blue. Yeah, alright, densities are all zeros. Huh. Yeah. Okay, so that's, part of the problem. They're all 0 because this... I'm stupid. This buffer, where we're updating the densities, where is it? Densities. It's being bound to the point cloud uniform buffer, not the cube. So yeah, that makes sense. Now we should be seeing different colored overlapping cubes. Alright, there we go. That's something at least. Yeah, okay. So I can kind of see the shape a little bit, I think. No, not really. Oh, I didn't add the model in here. That's probably gonna, yeah, there we go. Okay. Where was it? It was called cube push constants. Here we go. So scaled by 0.5, translated by 0.5. Hmm. Yeah, I think the cubes are still too big. What if I just change the scale of these vertices? What happens? So we're subtracting 0.5 from the position to get the center, and then we're adding 1. So that doesn't that make the cube actually 1.5 units across? Or or 2? Yeah, interesting. Okay. I do want to actually have depth turned on. Is it not turned on for this? Also, I guess culling. Cube. Yeah. Mo Chao says, hey, hello, how you doing? So we've got a fill. I'm going to cull the back of things, and then also... What was the other thing I need to turn on? Depth test is dynamic. Okay. So if that's the case... it is enabled, but I'm going to actually... Depth test enabled. I think I need to press the D button. I'm working on... well, right now working on 3D terrain generation, although it doesn't really look like that. D, there we go. Right, I'm going to remove this model. Where is it? Here it is. Not that one. Alright, there we go. Okay, so... we can go in the cubes. That's all good. What if we say... we've got the density going out, right? And then we go to the fragment shader here. What if we say if density is less than 0.5, then discard. There we go. Okay, so now we've got sort of 3D looking terrain. I think the amplitude is too high, and also we don't have enough of it. So if we go back to our noise 3D, there it was. Sorry, too low, I mean. I don't know if I should multiply it by 10. Maybe try this first. Maybe I should use a storage buffer and add more. Just more blocks so we can see a bit more. That's a bit better, right? So you can kind of see how this is turning into 3D terrain now, I think. Of course, the colors are a little bit garish. Interesting. It's going to be voxel terrain. Yeah, kind of. I mean, yes. Eventually I'm planning on doing something like I wonder if I can find an image of it. I can show an image of sort of what it's going to be like, but I don't think I've seen something that looks exactly what it's going to be like. Not like that really. Something like, where's that image? I just saw it. It's gone. So sort of like, yes, voxels, but the smoothness is, well, they're not cubes. We're not going to use cubes. We're going to use marching cubes, which gives you this sort of sloped terrain. Oh, actually, I can just show you the version that I've already got, I think. So this is the outdoor terrain that I was working on before, but I'm now working on indoor terrain. So I don't want to do outdoor. I don't want to do an outdoor world. I want to do a cave world kind of thing. You can kind of see here what I'm talking about. We just go down. You can see how it's all sort of sloped. Some weird effects there, but yeah. The sort of sloped kind of terrain. So if you can imagine, I think that this is using 3D noise, but I didn't make any caves. Yeah, anyway, something like this, but inside. And that demo is using Raylib, and I'm now using a different renderer, so I need to make everything a little bit differently. Also, I don't want to use triangles. I think I want to use ray marching, but I don't know how feasible that is. We'll see. Ray marching is really cool because you can get these ray marching 3D. You get these sort of objects that blend into each other like this. So this is a plane and a sphere, and they sort of look like they're combined, which I think would be really interesting for a horror game. You can imagine like a monster that's actually coming out of the wall like this, and sort of blending into it. That'd be pretty freaky. Yeah. Plus you get a lot of interesting lighting and volumetric effects like smoke and fog and stuff if you use ray marching. Do I have a GitHub? Yeah, my GitHub is GitHub Falconer D. I think that's how you spell it. I'll just zoom in there. I can't post in the chat. It says it's in read-only mode. Otherwise, I would post it for you. Cool. My GitHub has a lot of abandoned projects. I'm sure that's normal, actually. A lot of people seem to have abandoned projects on GitHub. Let's see. All right. Just want to get back to where we were. So we're drawing these really bright cubes, and what I said I was going to do in the fragment shader was something, right? Oh no, I did the thing. So we're going to discard if the density is below 0.5. Okay, that's fine. Now, in our model up here, where is it? I'm looking for, yeah, this. So we probably don't need to scale this anymore. Let's see what happens if we just send in the identity matrix now. Huh. That... Does that look the same? Yeah, it looks a little bit different. Oh, right. So these are actually supposed to be 1.0, is that right? Let's see. I guess so. Okay, so that was actually correct. I think they're not overlapping, they're just kind of see-through. Because, why? Don't I have the culling turned off? And the culling turned on and the depth mode off? Depth on as well, rather. So cube pipeline. Oh no, it's not on. I'm just gonna turn it on by default. True. It was set to a configuration button, so if I pressed it, it would turn on, but by default it was off. That's better. Okay, these colors need to change. This is too much. Okay, so we're just gonna say, yeah, that'll just be some kind of white, gray. That's, yeah, that's a bit less intense. That's better. Cool. This is a good step. So I would say that's nice. We're generating a little chunk there. That's cool. Now, there's two directions we can sort of go from here, I'm thinking. One direction I've already been down a little bit. So we've got one chunk. Why is that like that? One chunk rendering cubes. Okay. We can't interact with the cubes. They're not real cubes. They're just, you know, fake cubes made in the shader, but it doesn't really matter. I mean, there's no geometry on the CPU side. But if you use cubes, it doesn't matter because you can just check whether there's a block there and then do a collision detection based on that. So you don't actually need the geometry, really. However, yeah, as I was saying, there's a couple of ways we can go. So one is we can go down rendering more chunks, and so that would include things like multi-threading, multi-threaded rendering, multi-threaded chunk generation, terrain. I'm going to say sculpting or something. It's not exactly sculpting, but it's sort of playing with the settings until you get the kind of terrain that you're looking for. And then you would need, depending on how you're going to render the chunks, chunk stitching, which we're going to need. This is for marching cubes. And then, oh, actually that's sort of like a later step, so I'll just remove that. So let's just say something like this. And then the other path is rendering, getting closer or progress towards final version. That's not really a good title. So basically, I don't want to render chunks. So as I was just saying, I want to render using spherical ray marching or something like that. So this would be implementing maybe ray marching on cubes, and then later ray marching on marched cubes. So that would mean I had to implement marching cubes in the compute shader, I'm guessing. Compute shader. And so I've been down this road before. I think I should go down this one first, because I want to get the look of the thing working and then worry about rendering more of it. Because I know that you can render 1 trillion cubes on the screen, or maybe not 1 trillion, maybe like 1 billion or something, like no problem. But so that's kind of going down this path. So if I wanted to render a lot of cubes, I know that's already possible. But this stuff, I haven't really seen games that have done full ray marching, and that's because it's expensive. So I'm hoping that having the whole game set underground, sort of interior locations, means that we can do really aggressive culling and get a lot more performance, which means we can run these expensive algorithms on even lower end hardware to get 60 FPS. So my goal is 60 FPS at 1080p on a GTX 1060. Is that the one I'm targeting? 1060? Yeah, I think 1060 here. Which means roughly 400 to 600 FPS on my machine. I've got a 3090, so kind of just roughly calculate the difference between those cards and get something around this at 1080p as well. Of course, I'll need to actually check it on a real 1060 at some point. But yeah, that's kind of the performance goal. So I want to get some cool new tech, like ray marching is, it's not super new actually, but it's kind of recently that we can do it as well as we can on GPUs, I think. So yeah, I want to try at least some of this. If we can't get full ray march scenes, then I have a backup plan, which is we use the rasterized marching cubes, which is this algorithm here, which is a little bit laggy right now generating these chunks, as you can see, because I got to generate the buffers on the main thread, and I didn't find a way to speed that up yet. But so this is all triangles, right? This is all rendering triangles. The frame rate is, well, it's capped at 60, but I think it's totally fine. But you don't get as cool effects. But I got an idea for having using the triangle marching cubes, and then using ray marching for some other effects like lighting, shadows, and stuff like that. But yeah, so I think I'm going to go down this path first. So that means the next step for this is we got cubes rendering, but now we want to render something else. So maybe SDF cubes, perhaps? So that would mean we have a totally different vertex shader, because we just made a vertex shader that constructs cubes, right? Now we're going to throw that away, and we're going to try something else, which is fine. But I don't actually know enough about SDF, so let's have a look here. This is the website of, I'm not sure I'm going to pronounce this correctly, but Inigo Quilez, or Quilez, probably Quilez, I don't know. He's a creator of Shader Toy, one of them, there's two creators. So shadertoy.com. If you have not been to this website, it's really cool. You can just see people's amazing shader creations in here, and people do some really crazy stuff. So if we have a look at the browse, actually look at this, ray marching. It says warning, this shader takes too long to compile. Okay. That's okay. So this is a fully ray march scene. None of these shapes have any geometry. There's no vertex shader. There's no vertices at all. This is just one big fragment shader here, as you can see. This is the code, and then, I mean, look at that. It's got shadows, it's got reflections, it's got specular lighting. Wow. My computer just turned into a rocket ship. Holy crap. It's super loud. Yeah, it's pretty nuts. So yeah, that's pretty awesome. Shader toy browsing is one of your favorite pastimes. Nice. Okay, that's cool. I mean, look at this. This is a cable tunnel. I mean, those lights are a little bit intense, but yeah. point is, there's a lot of cool stuff you can do in shaders, and this guy who made this website also made tons of tutorials and little snippets about shader creation. So the thing that I'm interested in is, well, what's a simple voxel in his description here? Oh, this is tiny micro voxels. Okay. This seems like he just has a voxel renderer in the fragment shader. Wow, that's pretty cool. Look at that. So it's just generating a world with 3D noise inside the fragment shader. That's nuts. But the downside of doing everything in the shader, by the way, is that you can't interact with it on the CPU. All right, let's have a look. Mo Chow just sent me a link. Check out this one. All right, I'll look. Let's see. CNN digit recognizer. Oh wow. Oh wow, it's a neural net that can recognize numbers. That's pretty cool. That is very cool. Wow. Okay, people are crazy, right? I suppose it makes sense. I mean, that's definitely not an 8, but I commend the effort. That's cool. That's not a 3. That's a 3. Wow, that's nuts. Yeah, the problem with doing everything in the shaders is you can't interact with stuff. So the CPU has no idea. Like, for example, if we look at this again, the CPU has no idea that these are blocks or that they have anything. Like, there's no way for the CPU to know anything about those, especially since this one's in the fragment shader only, I think. What am I looking for? Select input. No, yeah, it's just entirely in the fragment shader, looks like. Which is kind of crazy. What is he doing? How long have I been doing graphics programming? Not long. I only just started. That's why I can't just pump some of this stuff out. I gotta look it all up. Maybe a few days, I guess. I've been doing other programming for a lot longer than that, though. Damn. So, the thing I was going to look at is 3D SDFs. We got a box. Box is the same thing as a cube, I guess. So this gives us the function. Emilio says, thanks for mentioning the website. Booked it. Nice. Yeah, it's really good. Also, this website by the creator. He goes by IQ online. I think that's what people usually call him because his initials IQ. This is a box, and this is the position that the camera is in, I think, or the ray. This is the box position, I guess. Yeah, see, but I don't have the requisite knowledge to implement the ray marching from scratch. But it looks like IQ has a bunch of examples here. This is crazy. This stuff's all made in the shader, huh? No modeling at all. That's creepy ass. Wow, so he's been doing this since 2008. That's a long time ago. So this, I guess, oh, okay, demo party. So he was part of the demo scene, which was making, as far as I understand it, really crazy visual and audio experiences that people thought were not even possible. And then also making them really tiny was part of the fun of it. So you'd open up a executable, it's like, 10 kilobytes or something, and then it would just turn into this big 3D thing with music and everything somehow. Yeah, pretty cool stuff. I don't know if it's still going. Probably. I have another article where I explain how to compute SDFs and much more complex objects. All right. I'm not going to watch a video on the stream, so we'll have a look at an article. This looks like something we want. Producing simple analytic shapes with ray marching engine is very simple, as seen in this reference article. Huh? Okay. Okay, let's just read the rest of this. Besides simple combination of shapes to construct more complex compound shapes, there is also the possibility to do this composition algorithmically. Probably the most basic way of algorithmic composition is the recursive introduction of regular smaller details. Okay, yep. This naturally produces classic Cantor fractals. Okay, I don't know what a Cantor fractal is. A set of points lying on a single line segment that has a number of unintuitive properties. Okay. Oh, like, okay, like this. Interesting. Mochow says, IQ is amazing. He even makes up trigonometry approximations so the GPU can be even faster. That is cool. That is very cool, actually. I like that a lot. A good example of that is the untraceable 1 kilobyte demo by TBC. Okay. Probably the most trivial example of that is the Menga sponge. Yeah, I think he missed a G here. Oh, this thing that we're looking at. This is the Menga sponge. Gotcha. Let's take this as an example and do more ray marching experiment. You can see the final result at the end of this page. I assume you already have some code working, and that you must have your basic ray marching intersection routine looking something like this. Well, I don't have that actually. All right, let's have a look. Basic ray marching example in the fragment shader, I guess. Okay, I really like this guy, Kishimisu. Very good YouTube channel. Definitely check that out. But as I said, I'm not going to watch a video on video. So let's have a look. Super simple ray marching example. This is the shader used in my ray marching tutorial. Okay, that's a link to this page. Created for 2017 shader toy composition. So I've got a map distance field function for the scene. It combines the separate distance field functions of 3 spheres and a plane using the min operator. Oh yeah, okay. So basically this is the scene. So all of the objects in the scene are being combined using min. I know about this already. And this function here is the sphere distance calculation, and then this is the plane, I guess. All right, and then calculate the normals. Oh, that's actually really simple. What? It's gonna take me ages to get my head around this because the code is so simple, but it doesn't make sense, if that makes sense. Because if we think about it, what do we got here? What's Q? I don't know what that means, which is not useful. RO is ray origin, RD is ray direction. So H is what? I don't know. Is H the current hit? I guess hit, and then T is time? What is T? T is time, I guess. So is moving one, whatever the direction is, 1 unit at a time. That seems like a really long way, actually. Oh, but it's being increased here. Oh, I see, I see. So you move distance of 1, and then you add in the return value of H, which is going to be the distance. So, okay, this is so confusing to me. So the distance field function combines the separate distance fields of 3 spheres and a plane. I understand conceptually what this is doing, right? So if you look at a 2D sine distance field, actually we can look at IQ's website again for this. You can imagine where like at this point here, then right, where was I? Here. We're going to get the distance to the 3 spheres and to the plane, and then we're going to return the closest one, right? Whichever one's closest. So if we're here, it'll return like this distance. If we're over here, it'll return this or something like that. And then if there was another object closer, it would return that, right? But I don't understand why that. I guess I don't understand why that turns into a 3D scene. You know? It's confusing. I'm sure I will understand it more. It'll take me a little while though. But yeah, I think we can use this to make something. So we're actually going to use, we're going to use this as an example. I'm going to make a shader. It's going to be SDF cube. Actually, it doesn't even have to be cube. I'll just call it SDF, I guess, for now. We don't even need a vertex shader, but we do need a vertex shader. I don't know what's going to be in it yet. Let me just think about that for a second. Frag sdf.frag.glsl. Okay, I do know what's going to be in here. It's going to be that making a rectangle on the screen, because that's what we need to draw the fragments on. So that's going to be... There's a couple ways to do this. I think the easiest way is vertex index shifted up by 1. No, I don't understand why this one works, so I'm not going to use it. So I've got to draw a triangle. I'm just going to draw a little thing here. We're going to draw 2 triangles. Stop that. Okay, we'll just pretend that our screen is this shape, I guess. Alright, my comments are italic, so that doesn't really that doesn't really line up very well. Maybe if I do backslashes instead. Oh god, it looks horrible. Okay, well you guys get what I'm talking about. We're gonna draw 2 triangles on the screen. Yeah, I should make comments not italic now that I think about it. And to draw 2 triangles in the vertex shader, how do we do that? Draw full screen quad vertex shader. You can also do 1 big triangle. I think that's actually way more efficient, but I don't I don't know the ramifications of that just yet. So the one big triangle, what I mean by that is, let's say this is your screen. And all we want to do is we want to draw pixels to divert the fragment shader, which means we could either make two triangles like this, one big quad, and we're drawing to these two triangles, or you could make one big triangle, something like, not like that, but a little bit bigger than that. I can't remember exactly the orientation that it's usually in, but let's just say something like this. And it has to cover the whole screen, so it's a little bit too small. And then you calculate the UV coordinates based on this triangle, and then you could just draw to this part here. And that's apparently much faster. But I haven't tested it, and I also don't know exactly how it works. So I'm not going to do that. So let's see. What do people recommend? Vertex shader can generate a quad. Everyone does it in such weird ways. Actually, I might already have a shader that does this. So if we go to my shaders, .vert, I can't see the preview, .glsl. So we've got that one, no. This one, what does this do? Yeah, convert to, no, that's not right. No, this is 2D, not the same thing. Depth only, no. Full screen quad, hey, look at that. Yeah, so this is the naive version, I guess. There's a better way to do this, but this way is very clear as to what's happening, at least. Yeah. I don't know what's up with the syntax, though. I must have copied this from somewhere. Because I wouldn't write it like that. I would definitely write it like this. So we already have the vertex shader that we need. That's cool. We can use full screen quad. And then we just draw vertex index. So we draw 4 vertices. Right? So we're done with the cubes. I'm gonna make another one. It's gonna be SDF. Alright, Emilio. Good to see you. Have a good day. Thanks for coming. So, the SDF pipeline. It's going to be kind of interesting, I guess. We do want the full screen quad and then the SDF fragment shader, I guess. Yeah. Actually, I know I'm just making the compile time longer every time I copy shaders, but vert. Why do I keep doing that? Replace. There we go. Alright, so we're just going to replace this fragment shader with, well, not replace it. We're going to say out color is going to be 0.0000.2, which is just going to put a big dark rectangle over the screen, I guess, just for now. Layout location equals 0 out vec 4 out color. All right. I'm actually going to change the build script, the other build script. How do I? No, I'm not going to change this one. I'm going to change the build script itself. I'm going to say I'm not going to call build shaders anymore. I'm just going to call manually build the ones that I want, which is going to be this command. Where is it? Shaders / SDF. What I should do is just set some set up a script to check if it's been modified, and just only recompile if it's been modified. I think that's right. No. Right, yes. Okay. No problem. Loction is not a word. Good to know. That's better, right? We're not compiling like 20 shaders. Alright, yeah. Big gray box over the screen. Kind of interesting that I can't see anything else. I guess there's no blending enabled. Which is fine. So, I don't think we need depth test. We definitely don't, actually. Fill, yeah, that's fine. Triangle strip, I guess, is okay. Depth, format, nothing. Do we need a... No, we don't need depth, so it should be fine, right? Yeah. Okay, now... all the way down here. So we were drawing... oh, what was this? Depth converter... cube pipeline... alright, here it is. I guess I'll just comment that one out. I'm gonna have to clean this code up at some point, but I'm definitely not gonna clean it up on the stream. It's too much boring drudge work. So pipeline, this is the SDF pipeline. All right, got it. SDF push constant. I'm just going to change it to push constants because it doesn't use anything different. This is going to be 4 vertices, 1 instance. Command buffer is available in the vertex and the fragment shader. We're going to need some kind of uniforms. Not command buffer, push constants, I mean. Depth test is not on. I think that should be good. Let's see. Okay. Bit of a problem. Something about the depth attachment. So, let's see. Dynamic rendering unused attachments. Oh. I'm getting used to the Vulkan errors. I've only been using Vulkan for like, what, a week? I think. It's starting to make sense. This. There's no dynamic depth here. Okay, let's read that again. Maybe I just misread that or read it too quickly. Okay, so we're not using the depth attachment. The format must match corresponding format in rendering pipeline create info depth attachment format, which is undefined. If the current render pass instance was begun with begin rendering, the unused attachments feature is enabled. Depth attachment view was not null. Okay. Let's see. Here. Pretty sure I didn't. Oh, I think it was in the rendering info. So let's go down to this pipeline. The rendering info here. Yeah, we've got a depth attachment. We don't want that. Yeah, cool. Yeah, look, you can kind of see half the scene. Huh, interesting. Why am I only drawing 3? Is the order wrong? Am I not drawing enough vertices? Do I need to draw 6? Probably need to draw 6. Yeah. Okay. Yeah, it was 6. But blending is off, so I can't see anything. But that's fine, because we're going to do SDF rendering right now anyway. So, let's see if we can get one sphere rendering with SDF. We'll start with that. That's apparently the easiest one that everyone does first. So I got the concept of this map, which is sort of everything in the level. So I'm just going to copy that, even though it doesn't really make sense for us right now. Maybe we can extrapolate it later. So I'm just going to say SDF sphere P, and then this is going to be the direction that we're looking from. So we need a camera direction. And then, I don't know why they subtract 1. What is that about? This is really big now. Let's just go, I'm going to close all these other windows. Look at this 3D SDF. So, SDF sphere takes, wait, what? P and S, and then there's nothing to do with, let me see. Okay, so all the lighting and stuff is done separately in the map function, I guess. Right, okay. Alright, we'll do the really simple version first. So no, not even a direction. Just a... What is S? Is it radius? Yeah, it is. It's minus the radius. Why is it S though? I'm pretty sure that's what it means. Because you want to subtract the distance from your point to the sphere and then minus the radius so that you get a negative value on the inside of a sphere. Okay. I'm going to call it R. I don't know. I know I'm going against the master, but I need to call it something else. I guess it's not SDF, is it? So it's SD sphere. That does make more sense. Sine distance sphere. Why did I put that in here? So the radius, I'm just going to set it to, that's the wrong language. I don't know, 0.5. That might be tiny. That might be big. I don't know what's what. I don't know what numbers mean. So let's see. SD sphere is going to take in a vec3 and a float and return length p minus r. Okay, return d. So then we could do something like d equals min D, something like this, right? That's how you would add more objects to the scene. So we're just going to start with 1. Okay. I'm not going to calculate normals yet, which means it's just going to look like a big circle. And look at this main image. So this is the ray origin. So I'm pretty sure we want the ray origin to be coming from the camera, but I guess we'll start with the super simplest version. Vec3. I'll use the nomenclature that everyone uses for this stuff, I suppose. 001. I don't know what Q is. This is actually the UV coordinates, I believe. So I need to get those myself. Not. I suppose I could do the same thing here. I could say, why is it called it Q? Where does he use it? He uses it in... yeah. The ray direction for the frag coordinate. Okay, I need to figure out what that means. We do have access to frag coordinate here, so it's gl frag coord dot xy minus 0.5 times. I'm gonna have to pass the resolution in. Resolution.xy divided by resolution.xy. Then the ray direction we can calculate based on the normal vector of Q with 0 as the Z. So this gives us the XY direction. That's what Q is. Somehow calculating the XY direction based on this. Okay, minus ray origin. Alright, gonna have to figure that out as well. So we've got hit and T. I don't know what T is supposed to be. For int I equals 0, he does 256 steps. We can probably just do like 64 or something. Actually, maybe I should just copy him first, and then we can change stuff later. So map RO plus RD times T. So that gives us our current next position, I guess. If H is less than 0.01. Break. So this is the epsilon. I'm just going to call it that. H is less than epsilon. So he does all the lighting stuff. I'm just going to say frag color, or out color equals white. And then otherwise it equals black, I guess. That should work, I think. We need a few things to make this happen though. We need to get the uniform buffer. So we're going to do layout, location is, use location 1. Uniform, I'll just call it UVO, I suppose. And we're going to have a vec4, which is the camera position, and a vec4, which is the resolution. The vec4 is just because of the spacing. I'll probably add some other fields to the W component and to the Z and W for this one, but for now this is fine. So this should be U resolution and U camera position. Okay, and if we go back to our main file here, we're gonna have to have a look at our buffers. So we've got SDF uniform buffer. So we don't need, oh, we actually do need that. So we actually have 2 buffers, right? Yeah, nice. So we're gonna get we'll pass in 2 vec4s. So this is going to be SDF uniform buffers 2, which we haven't updated anywhere. But we can see we've got here point cloud uniform buffer 2, blah, blah, blah. Copy this. Replace, change, point cloud to SDF. This has to be SDF data, I guess. Actually, that's fine. Yeah, pointing to, that's actually already correct. I don't know why I put a 1 in here. I was probably doing something with that. So this is going to be, UBO data is going to be the resolution. So this is going to be screen, is it screen or window? Window width, window height, 0, 0 for now. And we're missing something else. What is it? Well, maybe that's fine. I probably need to add the densities to here. What was it again? Oh, I know what the problem's going to be. Yeah. So the problem that we're going to have is that the UBO is on the fragment shader, and we've set it up on the vertex shader here. So we need to go up here and change this to fragment. And also this one, and then down here. That's fine, that's fine. And this is also fine, I believe. Syntax error in fragment shader line 9. I forgot the semicolon. Very good. Maybe this one is a bit better to grasp what's happening. Shader toy ID says Mochu. Okay, thank you. Let me have a look. Oh, cool. It has more comments, that's for sure. So what have we got? Part 1 challenges. Make the circle yellow. Oh, so this must be part of a tutorial series. Yeah, thanks. Okay. So this gives us the UV coordinate, like I suspected. And this is the eye. Okay. Screen to eye distance. That doesn't make sense to me, but okay. Or set position by camera field of view. Okay, yeah, this makes more sense. Screen UV is where the ray is hitting at. Direction is the ray direction from eye to the screen hit point. Okay. Alright. Didn't hit anything. Alright, that's cool. Let me see. Actually, now that I think about it, this could just be discard. And actually, this is kind of silly. We're checking again. This could just be if h is less than epsilon, then draw this and break. Actually, it doesn't really matter. Now that I see this. Whatever, this is fine. Okay, whoa, whoa, whoa. What just happened? Without screen to eye distance, it would be orthographic, right? Yeah, okay, I think I understand what you're saying here. So if we have a... can I shear? I can't really shear with this, so it's a bit hard to talk about it. But let's say we've got the camera, if there's such a thing exists, is shooting rays, right? I think this is what you're talking about. And then we've got a near plane and a far plane. And this has to line up, actually. And so we're talking about the distance between these two. Is that what this is? Essentially? So that gives you a perspective projection, because otherwise, yeah, if it's 0, then the eye would be like right up here, like looking directly out. And yeah, as you were saying, it would be orthographic, which would mean all rays would be shooting straight, and all objects would look the same size, regardless of distance in the scene. Okay, that's how you think about it as well. All right. Cool. No, we had a problem here. The fragment shader. Okay. Cannot apply location. Oh, I did it again. It's the binding. Alright, we got a... we got a something on the screen. Big, oval looking shape. So that's going to be 0.5 of the screen is my guess. Yeah, there we go. Hey Josh, how you doing? Yeah, I keep doxing you every time you come in here, sorry. I mean, hey Usi, how are you? I can't help it. So we're doing, we're learning sign distance field rendering. It's pretty fun. Pretty fun. Actually, you know what? I might turn back on the cube stuff. Where is it? I'm gonna turn the cube pipeline back on. I think that should just work, right? Well, alright, yeah. So the idea is we're gonna replace these shitty, crappy vertex-based cubes with signed distance field cubes. That's the plan anyway. We'll see what happens. So right now we're just drawing a big oval in the middle of the screen because we have no we have no what's it called? Aspect ratio. We haven't done anything with the aspect ratio. It starts up fast. Yeah, I guess. Let's see. I mean, it's just a renderer, basically. There's not really much going on. So, we actually don't need to be in this file at all. We can just go to the SDF fragment shader. Now in here we need to do something to make spheres look like spheres. Is it threaded? I do have part of it threaded for networking and for the other chunk generation that I showed earlier, but right now that's it, and I'm not using any of that, so not really. It's gonna be probably threaded. I mean, definitely. I'm gonna need to be very careful about the performance with the stuff that with the tech that I want to use and the targets that I have for performance. So I will need to do a lot of hard multi-threading stuff. So is it our UVs? Minus 0.5 times XY. Is that going to give us the same result? Screen UV is where the ray is hitting at. Let me look at the one I was looking at. Do they look a little bit oval shaped to anyone else? Am I imagining that? I think perhaps this one is more what we want. Looks wider than taller. Yeah. That's what I was thinking. This one is definitely a circle. So let's see if we can do something like that. Field of view is the vertical field of view in degrees. Okay, that's good. So where is this function even used though? Ray direction. Am I blind? It's not used here. Ray direction. Oops. Yep, I would like to know where that's used. Thank you. It's not used. Okay. Right, so I can just ignore that, I guess. Shortest distance to surface, I direction, min dist, max dist, blah, blah, blah. So this is the scene. So this all makes sense. That's fine. The sphere SDF is -1. Why is it -1? I guess if we change this, it's going to be small. Yeah, okay. So this should just be like radius, I guess, and then where is this? What do you mean? What do you mean no? Oh, I need to put the 0.0 in shader toy. Yeah, okay, cool. So the UV thing is different, right? So this is frag coordinate -0.5 times. You should probably make sure the top to bottom is 1, like the aspect ratio fix. I'm not quite sure what you mean by that. Let's see. So, oh damn it. So we've got this Q, which, as I said before, I thought was to do with the UVs. And I think it is. So this ray origin, screen to eye distance. Like he does a sphere with size 1 and it perfectly fits the screen from the way he calculated the UVs. Yeah, right, okay. So if I, for example, in my test here, make a radius of 1, then when I run it, I want this to actually be filling the screen as a circle. That's sort of the test case, right? So let's see, UVs. I'm going to copy this other guy's code, but I don't understand it yet, which is annoying. So we've got the frag coordinate, xy divided by 2, divided by the resolution, .y. Okay, that gives us the xy divided by 2, divided by the height. Yeah, I don't get it. I think I, in his case, is the... no, I don't know what that is actually. So I is going to be the ray origin, isn't it? Isn't that what ray origin is? You can output the UV as out color and you will get it. Oh yeah, okay, that's a good idea. Let's hope I'm not too stupid. Actually, I'll just do this. Well, it's white because it didn't build. Yeah. Okay. Whoops. I'm just going to delete this. Okay. Blue to purple. I don't get it. Let me make this a 0. So red to green. Oh, okay. So UV1 is going to be all the way up there on the y-axis. That makes sense. 0, 0, 0. No, it's down there. 0, 1. 0, 0, 1, 1. Okay, so we're going from the top left to the bottom right. And green, Y, and yeah, okay, I get it. But let me just read this again. So the frag coordinate divided by 2. So if we're in the middle, the frag coordinate would be 540 by, what is it? No, something by 540, 1080 by 540. Sorry, 1920 by 1080 is 960 by 540, right? So that's like the middle of the screen, let's say, and then divide that by 2, and then you get, what is that? What is 960 divided by 2? It's 480 by 540 divided by 2 is what? 260, 270? And it's upside down. Oh, okay. Interesting. All right, and then we divide it by the resolution. Yeah, WebGL has Y up, but Vulkan has Y down. Yeah, that might be a problem. It's already been a problem for me multiple times, actually. Okay. So 480 divided by 1080, what is that? 0.4. I must have done this math wrong. Let me see. 1920 divided by 2 is 960, that's right. Divided by 2 again is... No, I didn't do it wrong. Divided by 1080, 0.4. Oh. Okay. 270 divided by 1080, 0.25. So 0.4, 0.25. Oh, yeah. I think this might be... That seems weird to me. Okay. There's one part I'm not getting about this, which is like 480 divided by 1920 would be 0.25. Right? That makes sense. But 480 divided by 1080 is giving us 0.4. Why is that the correct UV coordinate for the x-axis? Is it because it's on a triangle? Alright, well, I'm going to say I partially understand that. I'll come back to it. I'm working through some documentation and some courses about shaders, so I'll get better. Alright, so we got the... This is the eye position, I think. so I'll just call it the same thing that he did, I, okay, and then the screen to I distance is going to be 2.4. I'll just set it to the same thing. Screen UV. So this is a 3D vector. So this gives us what? How far along the z-axis until we hit the screen? Yeah. And then the direction is going to be normalize screen UV minus the I. He also does minus I resolution.xy. I missed that in the UV. Did I? Oh. Yeah, okay. This could be why I was confused. Let's have a look. Oh no, I was doing, in my head I was doing this already, but I didn't do it in here. So let's have a look and see what that looks like. Right, so we're centering the UVs. Oh yeah, I've been over this before. Okay. Okay, so now we're going from, well, it looks like -1 to 1 on the UVs. Okay. Now the direction is the direction from the eye to the screen hit position. Okay, that makes sense. Normalizing, subtracting these vectors makes a direction. Now the distance. You think it's minus 0.5 to 0.5. Okay. All negative values show up as black. So I don't know, that looks like a pretty bright red. Because this would be, if this was 0.5, then it would only be half red, right? Let's have a look. Got a little color picker here. Oh, yeah, you're right. It's not. It's only E20000, which is 226 on the red. Kind of interesting. This one is 127 on the green. What? Is this incorrect? So that one makes sense. 127 on the green is exactly 0.5, right? 226 on the red. The color space. Right. Yeah, I'm using unorm, not sRGB. Maybe that's why. I don't know. All right. Like sRGB in the middle is not 0.5, adjusted for how I perceive colors or something, but I'm not so sure. Okay, fair. I don't think I'm using sRGB anymore. Oh wait. No, I just require that we have it for some reason. I guess that's just how I made the swap chain. But the swap chain format is actually, I think it's unorm. The color format, yeah. I actually like unorm more. sRGB was way too bright. I think unorm works better for the game that I'm making. Because I haven't experimented that much with color space. Distance is, this is our map function. So, oh no, it's actually like rolled up into one. So I'm gonna do for int I equals 0, I is less than 64, I plus equals 1. D equals map P, no, what does this have? I plus depth multiplied by matching direction. Apparently in the end you want an sRGB, but you do the math in linear space. It's kind of confusing. Yeah. But with just 8 bits you can have banding at transitions. You won't be able to do any HDR in the future. Alright, I'll worry about that when I have to, I guess. I'm going for a pretty lo-fi kind of look anyway, so maybe it's not going to be a problem. We'll see. Dandy says it depends on your image editor. Some save images in sRGB, some not. Right. We're talking about the rendering engine though. I don't know what you mean by that exactly. Although I never thought about it, but yeah. This would affect all programs where you do art, right? If the image you're loading into your texture is sRGB, you can either map it to linear space using the graphics API or manually in the shader. Right, and then you can do gamma correction to get it back to the correct visual space. Okay, gotcha. That makes more sense. What are we doing here? Map. Let me read this. Return the shortest distance from the eye point to the scene surface along the marching direction. If no part of the surface is found between start and end, return end. Okay, this is the ray origin. This is the direction to march in. This is the start. And this is the maximum distance before giving up. Okay, yeah, I guess it makes sense to functionalize it. Turn it into a function. I'll just call it the same thing. Shortest distance to surface. Direction. Start and end is floats, okay. Alright. Do I know art of code is cool? The art of code is cool on YouTube? No, I don't. Let's have a look. Oh, nice. Shaders. Shader things. Ray marching. Dandy says this is for OpenGL, not Vulkan, but it is a really nice summary. Oh yeah, Learn OpenGL is a really good resource. I like it. Okay. Yeah, I'll take a look at this. Yeah, it's got overgrowth. Oh, interesting. I like the one on the left more. Oh, he actually talks about it's gamma corrected twice. Okay, that makes sense. So, alright, okay, interesting. Yeah, I'll check it out later for sure, and I'll check out this. This channel looks good. Graphics programming is really fun. I wish I got into it earlier in my life. Like back in high school would have been ideal. Okay, just gonna copy this pretty much word for word. Dist equals min, not min. It's kind of fun to ignore gamma correction for a year and then go back and fix it one day and get a massive visual improvement instantly. Okay, fair. Epsilon, alright. Return depth. Okay, so we hit something. Otherwise, we continue, and if we went further than we should, then return end. Okay, that makes sense. Also, this could just be a break. It's kind of like when you write a bunch of silly code, then optimize it one day and get double the FPS. Yeah. Yeah, for sure. And sometimes that can be really simple optimization as well. Not even anything difficult, which is nice. Okay, so we got... Oh man, I need to take some more Panadol or something. Normalize. No, we got the direction already. Distance equals shortest distance to surface. Direction. What have they got set as the min and max distances here? 0 and 100. That'll do. I'm going to need to move the epsilon value up. If dist is greater than... I don't have max dist, so let's do 100 for right now. We didn't hit anything, so I'm going to discard. Otherwise, we set the color to the UV coordinates, I guess. Okay. That didn't build, I'm guessing. Yeah. So I forgot a semicolon, I think, looks like. Huh? No? Yeah. Forgot the I there. Nice. How long have I been using Odin, and what other languages do I use? How long have I been using Odin for now? Maybe a year? Or a bit longer? Before that I used C, Zig, Rust, JavaScript, TypeScript, C#, Elm, which is a functional language. And I tried F# for a bit. I was going down a functional pathway. Hey, the dot wolves. Okay, thanks. I'll add a link to the Twitch. Yeah, I haven't, how do I say? I haven't gotten all of my shit together, let's say. So I thought I would try to start a streaming habit. So I'm just streaming 6 times a week. And then if I successfully do that, I'm going to fix like all my social media, changing my website a bit, and then like making sure everything links to everything, making sure everything's valid. But I thought there's no point doing all that stuff first, and then if I don't stream, like it's just a waste of effort. So yeah, thanks for that. I will definitely add that. All right, that's cool. So we got, that looks like, yeah, that's right. So we're drawing the cubes. We're drawing a big sphere in the middle of the screen so we can't see anything. Very nice. Okay, so our scene currently consists of one sphere with a radius of 1. It's always in the middle of our screen. Now, how do we make this into a 3D projection? That's the next step, right? Because we want this to be a sphere that's at a position, not a sphere that's just in the middle of our screen all the time. So what we've got here is SD sphere. Actually, I think I can look at this example to get sort of an idea. Although the code is a little bit dense. And it's quite complicated. Let's see if I can actually find 3D ray marching. Yeah, thank you. When mathematicians write code. Yeah, I mean, that's true, but also they make really cool stuff, so I can't really fault them for that. This looks, I mean, there's a lot of, it's got like, okay, BRDF and that's fine. I don't care about the shader, I mean the material stuff. I actually just want to know about the projection. So let's see. So I've got an eye. What the hell does that mean? So 8 times cosine, yeah. So we're gonna go around on the x-axis. Okay, so we're rotating around the origin, that's what this is. And the target is 0.3 times rotating around the y-axis. Oh, I get it. Okay, so we're like, that's weird. Yeah. Right, it's not like fully locked when it goes around. It's like it's a little bit off because of this. Okay. So that doesn't really help us. It looks like it's in 3D space. I mean, it is in 3D space, but we want to be able to move our eye position. Camera's pitching up and down slightly. Yeah. I suppose that would be this part here. Okay, so like if I change this to a really large number, or a much larger number, what happens? Yeah, there we go. Whoa. Crazy. Yeah, anyway. I keep forgetting you can just change the settings in these shaders. But I kind of want a... Actually, I got an idea. If we pass in the target from... yeah, exactly. Expanded form of a lookat matrix. Thanks, Dandy. So I'm thinking maybe I just pass it in as a uniform from the CPU. Right? That would work, right? Where are we? I gotta make this bigger. So we've got a few push constants. And we have a projection, a view, and a model. But what if we also passed in a... Wait. The view is a lookat matrix, so we already have access to it. We have access to it plus the projection. And that's normally what you do to save calculating the same trig functions a million times for every fragment. But on shader toy, everything's a frag shader, so the code's always like that. Yeah, that makes sense. So I'm thinking we have the push constants here. Push constanto. Uniform, I'll just call it push constant, whatever. And we've got MVP. Now, I still haven't gone over enough of the matrix multiplication part of the course that I'm following recently to understand how we've got this, actually we just have VP, view projection matrix, and how I can apply that to this. So if we look at this, we've got eye and target. So the eye is the position of the camera, right? But the thing about ray marching is we're always projecting everything onto a quad. So we're not really... Like the eye position is not the same as the camera position, right? In a scene. Is that what that's what I'm trying to get at. So we've got a camera position actually already here. So if I put the camera position in here, what happens? I equals camera position, yes? Okay, let's have a look. I think this is gonna break because, well, I just think it will. So where's the, whoops. Okay, so this is not great. I'm teleporting to the origin, but the origin is inside this big cube. I thought maybe I'd be able to see something, but see, this is target is for lookout, which makes sense if you're orbiting, but if you want a normal FPS camera, you would instead calculate a normalized basis from a forward and up vector. Right, yeah. What? Where am I? Alright, just give me a second. I need to take some more cold medicine. My head's getting very foggy. Also gonna make another coffee, so I'll mute the mic. Hello, hello. Hopefully I'll start to feel better in about 10 minutes. So, I was thinking a little bit about our problem. A ray march explanation of ray marching. Okay, excellent. I was thinking either I need to find a tutorial that kind of walks me through each step, or I need to start drawing some diagrams and figuring it out. Because, I mean, really, drawing ray march, wow, okay. You will learn how to render a 3D scene in shaded toy using distance fields. Press space to continue. Alright, let's have a look. As an example, we'll create this black and white scene of 3 spheres on a plane. First, we create a ray. The ray origin will be at position 0, 0, 1. Okay. This is cool. What? I guess he's using SDF font rendering, right? Pretty nice. Let's see. Yep. Definitely an SDF font. Yeah. So we already got this. Blurry with an outline. Yeah, have you guys seen MSDF? The multi-channel SDF font rendering. It's really nice. It's on a shaded toy? Yes, it is. Okay. Sure, why not? I guess let's just walk through this. Why not? Let's have a look. So we don't have to do anything except modify our shader. SDF works good for smooth shapes. It breaks if you have weird corners. Yeah, that's why I was referring to this MSDF font rendering. So this is what you're talking about here, right? So it's got these breaks here. Looks a little bit round. Whereas with this new technique, multi-channel SDF, helps a bit, but it's not perfect, really. Okay, I used it, and it looked pretty good to me, but I've only used it once, so that's fair. I don't have a lot of experience. Let's see if we can walk through this tutorial here. So we got our main image. We're going to get the ray origin 0, 0, 1. Very good. Okay. We're going to set up this Q, which is the UVs, right? It's mostly fine with Latin characters, but if you start having Chinese glyphs or accents, it can cause problems due to close, sharp edges. Oh, I see. That makes sense. I only tried English characters, or Latin characters, as you more accurately put it. By the way, English should get a new alphabet. Just saying. It's just kind of lame that we use one from another language that doesn't really make sense for us. It's nice because you can do tons of neat effects. SDF is very popular from Team Fortress 2 era. Never heard about MSDF. Yeah, I think Valve made the original SDF font stuff, right? Or maybe they just popularized it. Alright, so Q equals fragcore.xy times, was it minus 0.5 times resolution dot xy divided by resolution dot y. Okay, this is looking very familiar. Now I've got the ray direction here. We're going to normalize the vector from Q to minus the origin. That makes sense. Normalize Q minus origin. They wrote the first major paper on SDF, right? Yeah. Now we can place, yeah, see, this is what I was thinking in my head. I'm like, isn't projecting onto the two quads exactly the same thing that we always do when we're projecting onto the screen buffer? You know, when we just do normal rendering. So I was thinking it should be like the same, but I guess I just don't have enough of a grasp to just write it out. So we place a virtual screen in the scene. It's located at the origin and has dimensions of the aspect ratio times 1. Okay. Man, this is cool. We compute the ray direction for each pixel. I'm going to have to look up who made this in a second. We compute the ray direction for... you have this ready with the view projection matrix. Yeah. Wait, you can drag the mouse? Oh, no way. What? That's cool. For each pixel of our virtual screen. Okay, understood. So the view projection matrix just transforms a 1 by 1 by 1 cube with the matrices to get the corners. Alright, so in code, alright, we've got this main image, yep. That's exactly the same. Okay. Distance field is used to find the intersection of our ray. RO, RD, and the spheres, and the plane of the scene. Yep. Okay, gotcha. The distance field is a function that gives an estimate, a lower bound of, the distance to the closest surface at any point in space. Hey, is chat not showing up on my screen? I just realized that. Man. Oh, no, I have to fix that next time. Sorry, guys. Twitch chat's supposed to show up on the screen. The distance function for a sphere is the... yeah, gotcha. Okay, that makes sense. Oh, that's cool. Hey, look. Spam. The code for a sphere is the sphere located at -1, 0, -5 is this. I don't have any mods. Very funny. So this is pretty much what we were looking at earlier, actually. Okay. Gotcha. We combine different distance functions by taking the minimum value of these functions. Okay. I guess I'll just write this part out. Actually, it's pretty much the same. That's alright. We will just comment out this stuff. So I'll probably still use that sphere function. Not void. We want to return a float. And takes in a P. So we got, what is it? -1, 0, -5. Is it the right? Oh, no? Oh, we need the distance. Yeah. What am I doing? -1, 0, -5 is the vec3, and then we put a radius of 1, I guess. That's what the -1 is for. Let me do distance. Can I press D, please? Distance. There we go. Oh, but it's distance. Yeah, that should be fine. Wait, no, I don't need this. Wait. I'm confusing myself now. Because we get the length. Oh, I think we need to subtract. Alright, I'm going to copy this directly. Alright, distance, P. I just don't want to do extra work with my brain that's not working. And then we use the min. Yeah, that's the same as before. So the min of D and the next values. So just copy this. Paste it here. Is that correct? Yeah. Right, but this is going to be 2, 0, and 3. And this is going to be -2, -2. Alright, fine. So we've got 3 spheres in our scene. And the plane is going to be, yeah, D equals min D py plus 1. Huh. That's going to be the wrong direction for us, isn't it? Well, let's find out. I think that's going to give us a ceiling rather than a floor. Maybe not. No, it's going to give us a floor. No, it'll be fine. -5 and 3. Oh, right, yeah. Right. Thank you. Okay. Now, the total distance function for this scene, including the plane, is given by this. Yeah. Now we can march the scene from the ray origin in direction of ray direction. Each step size is given by the distance field. So the initial step size is going to be to the closest point, and then we step by this amount here, and then this amount here, and then that amount. Yeah, that makes sense. Oh, that's cool. You can move it around. That's crazy. These people are crazy. We stop the march when we find an intersection. Cool. This is exactly the same code that we tried earlier. Like, everything's the same. So I wonder if it's the same person or if the other person followed this tutorial. I guess I'll use 256 as well. I did this last time. So h equals map of the origin plus the distance times the t. T is the amount we're going to move. Did I say distance? I meant direction. So that's going to give us the closest, and then we add the closest to t. Right. Oh, I see. Yeah. Okay, that makes sense now. Yeah, I'll just leave this at 0.01, then break. Very good. Use a mouse to interact with the scene. My Narco says, I saw you had a few previous streams with SDL3's GPU API. Do you think it's particularly efficient and useful for 3D rendering, or would it be better just to write a renderer in WGPU or OpenGL? I don't think I have enough experience to make an informed, to have an informed opinion about that. But what I will say is, it's a very nice middle ground between OpenGL and Vulkan. For me, it was anyway, because it's got a lot of concepts that you need from that you need to understand to use something like Vulkan or DirectX 12, but it doesn't have anywhere near as much uniform buffers, or maybe not fixed amount, the fixed binding sets for uniform buffers and things like that, so you need to read the documentation properly. But yeah, it makes you what was I saying? It sort of teaches you the in-between steps of something like OpenGL to Vulkan, yeah. All right. You can usually query the resource limits of any API that has hard limits like OpenGL. From code, yeah. The reason that I'm not using OpenGL is not really because of performance, because I'm pretty sure that it's just fake news that you can't do high performance stuff in OpenGL. For me, it's because I want to learn the graphics API that's going to be the one for the next 20 or 30 years of my career, which is going to be Vulkan, I'm pretty sure. It's definitely fake news, yeah. Laughing in 8,000 FPS, yeah, yeah. Now that we've found the intersection P equals RO plus RD times T, for our array we can give the scene some lighting. To apply diffuse lighting, we have to calculate the normal of shading point P. To calculate the normal, we can take the central differences on the distance field. Okay, I suppose we shall do this. So we need just a... Wait, why is this an in parameter? What does that mean? Does it mean it's going to be modified? No. I don't know what that means. So times 0.0005. What is this? So this is the epsilon. I guess we're making a little epsilon value here. Yeah. So we're going to normalize a OpenGL is fine for most 3D games and indie dev would be working on. It still has full shader support, which is where most of the heavy lifting happens these days. Yeah. Yeah, you can do pretty much everything that you might need. Compute shaders work. Managing the state is much more annoying and black boxy than Vulkan, both a pro and a con. Yeah, I did have a bit of an annoying time with creating buffers and stuff, because you have to do it on the main thread, and then I'm sure there's a way to make it faster, but yeah. I just decided to make the switch, because I've been doing OpenGL since 2019 or something. Although I usually do 2D games, so my experience was pretty limited. Well, when I say games, I mean prototypes, I guess. You think web GPU looks great, feels like the right amount of abstraction. You did Vulkan for 4 years and it feels too exhausting. Only playing with web GPU lately. And it's multi-platform. That's fair enough. I'm planning on writing a bunch of abstractions for Vulkan eventually, but I don't want to do it too early. Because I will get them wrong. Oh, this is annoying. YYX, YXY, XXX. Okay, I think that's good. We need to do nothing else. X, Y, 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 X, Y, X, Y, X, 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 yeah. You made a few 3D engines in C and OpenGL, got plenty far with it, but 3D is hard no matter what API you use, and a lot of the problems have nothing to do with the graphics API anyways. Rendering is just one part of the whole problem. Physics is the main difficulty, but also animation is quite some work. Yeah. There's a lot of interesting problems to solve, huh? We calculate the diffuse lighting for a point light at position 0, 2, 0. So that's going to be up here somewhere. Okay. I didn't actually calculate the oh, there we go. OpenGL is great. The only issue is it has a ton of legacy, like obscure methods that you see only being used in a single game. That's interesting. Okay, so we got our H value back. If it's less than epsilon, then what? We set the position to the hit position, so RO plus RD times T. Okay. RO plus RD times T. That's going to be the hit position. Calculate the normal. Based on the position, we set up a light, which is going to be 0 to 0. Okay, and now we get a difference between the dot product of the normal and the direction to the light. Okay, that gives us how like shiny it's going to be. That's cool. Clamp dot normal normalize light minus P and then 0.1 and 1. Yeah, that makes sense. Right, 0. No, 0 and 1, not 0.1 and 1. Multiply it by 5 divided by the dot product of the light direction to the point again. Wait, what? That's confusing. Dot product of light minus P and light minus P, wouldn't that just be 1? Or 0? Oh no, it's 3D. Let me think. Yeah, I don't get that. I need to figure that out. Like, how can you take a dot product of the same vector and then it not be the same as just writing 1 or would it be 0? I don't remember. Is it, if they're aligned, is it 0 or is it 1? I think it's 1. And 0 is at 90 degrees. But it's a 3D dot product, so maybe there's something different I'm not thinking of. Frag color is... Oh, that looks like a familiar pattern. I've seen that before. So out color is going to be 3 pow def 0.4545. Okay. Now we're done. Adding ambient occlusion, fake reflections, soft shadows, blah 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 is left as an exercise for the reader. Alright. That's cool. Let's see if we actually got what we wanted on the screen, because I got a feeling that I did something wrong. Well, that's definitely incorrect. Excellent. Alright. Let's see. You can find this shader here. So it's taken from ray marching primitives. Oh, that was this one. The dot product with a vector with itself gives the squared length of the vector, says Verdang. Huh. Okay. Thanks. I don't understand how that works. I can't really visualize it. So we probably want... Hope your side shadow is not impacting my work. No, not at all. It's great. I mean, who's going to explain to me about dot products if you guys are not talking? Let's see. What do we got here? Main image. Alright, so this is going to be way too difficult. I need to look at a different one. Okay, I think that's right. Okay. So if we hit, then we do this, otherwise we do nothing. Okay. So what if I just do this? We can narrow down the problem somewhat. Ah. Right. Well, so that shader wasn't even running. I should have checked. I cannot convert to a return type. So we're returning a float. Yeah. What's the problem here? Cannot convert return value to function return type. Okay, calculate normal. No matching overloaded function found. Cannot convert from vec3 to float. Alright. Well, that's one problem. And also, yeah, this returns a vec. What does this return actually? Okay, I've got our main image. Explains distance fields. Okay, we're mapping the scene. And yep, that's fine. We're marching. Now I've got to calculate the normal. So we're returning a vec3. Right, yeah, of course. We're swizzling these to vec3s, so we've got to return to vec3. Why am I returning a float? Also, it doesn't make sense for a normal vector to be a float. I'm not using my brain. Well, that's interesting. As I suspected, we did get a ceiling instead of a floor. So we need to modify this somewhat. Where is it? Where is it? Up here. So I think we're gonna do... Can I do -1? Will that work? No. We need to reverse the... Stop that. Reverse the y coordinate in another step. So it's kind of interesting that we just get all this crazy noise. I guess it's because I'm not discarding. Is that why? Oh yeah, I can't do that. I need to do an else. Okay, yeah. Wow. That's cool. Alright, so we have an upside down scene rendered. But here's the thing. Yeah, nice balls. Yeah, I like them. That's fine. I don't really care that it's upside down right now. The thing is, I don't know how to translate this into a 3D environment. That's kind of the next step that I want to take. So, if we have a look at our little diagram here, this is where we're drawing onto this flat plane, but the camera is like moving with the plane instead of when the camera moves, the plane intersects the world in a different spot. If that makes sense. That's kind of how I think about it in my head. So I guess I've been spoiled by just setting up model view projection matrices and not worrying about it, because it's just really straightforward when you do that a few times. So you just get this sort of pattern here, view projection, and you multiply your vertices by the matrices. Does that make sense to me? Multiply these in 3D space. Whereas with this, I mean, what if I multiplied these by the view projection matrix? Would that even work? I think it had to be vec4 with a... Would it be a 1 on the end? Maybe I could... No, I can't multiply... Yeah, it'd be a 1 on the end, and then it would be something like maybe this. Don't know if that would work. Thought you would just use a uniform camera position. So I leave this how it is. Now you're just projecting. Okay. Very nice. So you mean this, right? Hint is to transform the position 0001 and 0011 with the view projection matrix. Just be aware of the inverse matrix. Okay. Well, thanks for the hint. I don't quite understand what that means. Because, like, let's see. If I change this to u_camera position, I think we're going to get a very... We're not even going to see anything, right? Oh, we're just going to see... Okay, we're like inside the plane or something. Actually, I'll remove this plane. Okay, so the plane is not there, but also nothing is there from this perspective. Because we need to do another transformation, I think, but I don't quite understand. You need the direction from your flying controls. It's a bit hard to explain in small chat tasks. Yeah, I know. That's why I wanted to find a text tutorial that walked through this part. Like a 3D camera. Maybe there's one on IQ's website. Let me have a look. Whoops, I just clicked something. Useful maths. There's a lot of useful maths there. Is there anything with camera? No. Perspective? No. Start from the view matrix. What happens when you transform the 0001 position with the view matrix? Well, 0001 with the view matrix. Let me see. What does the view matrix look like? It looks like... Oh no, I've got it combined with the projection matrix. That's a good question. I don't know what happens. Let me have a look at it. View mvp.view. Yeah, see, we got a lookout matrix here, so I don't actually know what that is. Are we trying to explain what W is? Because that's black magic. I do understand that reference. So, rotation will not affect it, right? But the last row / column is the translation. Yeah. So view is not mvp.view. So this is our view matrix, which is... is there a matrix viewer in here? Matrix, maybe there is, but... I'm gonna say this is vec4s. Damn. All right. So we've got... I'm trying to construct this as 2D in my head, but it's a little bit tough. 1, 0, and then -5. The last row / column is the translation. Oh yeah, you said that already. I mean, I read that already. All right. Well, I think actually to get to the next stage of this, I'm going to have to go and do the matrix math refresher course that I was planning on doing tonight. Anyway, so then we can project things into 3D space instead of being on the screen and actually understand what that means. So I think this is as far as I can take it, and actually we're out of time anyway, so I want to thank you guys for coming. And I guess tomorrow, what day is it? Monday. Yeah, tomorrow I will have refreshed my knowledge of matrices, and then we can actually figure out how to project these spheres into 3D space, and then we can project the cubes, and then we can move on. So, all right, thanks guys, and take care.